Hello everyone, so welcome to this third lecture of week 7. So we have been discussing about various applications, and in this lecture we'll discuss about dialog systems. So we'll first describe the idea of conversational agents. What do we mean by conversational agents? And we will focus on open domain dialogues and how do you typically generate the responses. So we'll see the response per generation paradigm. And we will also talk about evaluation, that how do you evaluate a system that you develop for open domain dialogue. So what are conversational agents? So typically we also know them as dialog systems, dialog agents or chatbots. And so we are using personal assistant on our own devices, on our phones, on our laptops and so on. And I mean Siri, Alexa, Cortana, Google Assistant, right? All of these are assistants that we typically use. And they can be used for various tasks, for example, playing music, setting timers and clocks. You can even chat with each for fun. And many agents are also used for specific tasks, like you can do travel reservations and also there are some for mental health, that you can converse for mental health, right? So there are various use cases for conversational agents. Now, the first such conversational agent was built in 1966, was Elijah, and this was built based on certain very interesting regular expressions. So they would look at some expressions and then they would tend to repeat the argument. For example, like here, you see, in what way? They are doing something. Can you think of a specific example? Made me come here. So okay, so they are repeating the same statement. Depressed. So if it catches certain keywords, it will say, okay, I'm sorry to hear that. So it will have various interesting patterns that it was built upon. And one of the very first chatbot that was also very, very popular at that point of time. Now things have progressed. I mean, this is like one of the latest chatbots before we had this boom in the LLM based agents like ChatGPT and so on. So Blender-bot 2, 3. I mean, this had many versions, 1, 2, 3, and this was actually quite good. We will just talk about its design briefly in this lecture. And nowadays we all converse with ChatGPT and agents like that. So there is one particular conversation. So what is important about dialogues is that you will have multi-turns. So when we said question answers, we typically had a question and you would get an answer to that, right? And that's where it stops. But in dialogues, you would have a conversation that will go for multiple turns, right? So that is one way to quantify a dialogue, how many turns it typically has. And this is one of the important problem, that the dialog system should be able to make use of turns, I mean the memory from the previous conversation that has happened. Now when we talk about the types of conversational agents, there are typically two that are most prevalent. So one are known as simple chatbots. There you will be conversing with these just for fun, right? So and even sometimes for therapy. So they are mimicking the informal human chatting. And the second type of agents are dialogue agents that are more task based, right? So you will have like you want to perform certain tasks like setting the timer and playing music and booking a reservation in a hotel and so on, right? So they will typically have a specific task, and the way these dialog systems are built and evaluated is also very, very different. Okay, so for example, what happens in task oriented dialogue? So this is for, let's say, booking a train, right? So what will happen? So you will have multiple turns. So let's say user 1 and user 2 is the system. User 1 is conversing with the system, and user 1 starts by saying, hey, I need to catch a train from Stevenage to Cambridge, right. So now immediately the system will pick up what is the task the user is looking for, that's known as the intent. So the intent is the booking of train, right. So once you know the intent, there will be a specific number of classes of intents that are defined as per your use case. Now for an intent, you will have certain slots that you want to fill, right. I mean, so for example, if you want to book a train, you need to know, I mean, what is the source, what is destination, which day you want to book the train, and so on, right. So for example, here the user already provides the slots, the source and destination, but you do not know what day. So you can, the system can ask what day will you be traveling, right. And then the user is supposed to provide the answer, that is, I need to leave on Wednesday and arrive even the timing, so on no later than 21:45. And then the system can return back with a particular recommendation that, yeah, I have a particular train that arrives right, as per your constraints, and should I go ahead with the booking. And then the user may further ask, like, how long will the trip take, and then the system is responding to that, right. So you see, so here you have very specific schema, so where you have certain intents, and each intent will have certain slots, and based on the slots, when the system knows all the values of the slots, it can make a recommendation and can provide an answer to the system, right. So these are task oriented dialogues, and there are open domain dialogues that are just chatting for fun, right. So and doing the same schema design becomes very complicated, because now you can talk anything in the world, right. I mean, this is not about just booking a train reservation or so on. You can talk anything, right. So it becomes difficult to define the belief states, intents and all for an open domain. So that's why what becomes important is that you learn good representations that we have been talking about, and try to make use of encoder decoder kind of architectures, right, and also like how you define proper loss functions. And that's what will be the focus of this lecture. So we will talk about how do we deal with open domain dialogue. So this is one example. So like here, I mean, conversation between in a family. So mom, what are you going to make tonight? Curry and rice. What do you think? That sounds nice. I can peel the potatoes first, and so on. Right? It's a conversation between two users. So that's what typically you would like for fun and so on with the system. So dialogue modeling is very challenging, and more difficult than like things like question answering, because you need to interpret the context very well, right, and handle the background knowledge and extract relevant information from the context. And this is something that becomes very challenging once the context goes beyond a certain limit, right. So how do you store what are the relevant information from context that you need for generating a response? Of course, the data would be limited, so you have to learn from that. And this particular picture, I mean, just tells you another interesting aspect about dialogue modeling. So you have this Ben practice at my house 6 to 8, and the typical response is thanks for the reminder, right. But you also have a response thanks for the warning, right, depending on the context. Like particular user may see it as a reminder, some may see it as a warning, right. So, and which may be a completely valid response, right. So we will talk about that towards the end, that how do you evaluate a dialogue response that the system is generating. Okay. So now, yeah, so going to this open domain dialogue, so typically we have to learn from data, right. I mean, so we are saying we want to chat with the system, so we have to learn from the data how previously users have conversed with the system. So there are two typical ways in which these models work, the architectures work. So one is response by retrieval. So what is the idea? So you assume that you have a large repository of user, some context, some user query, and a particular response, right. You have a large repository of that. Now whenever a particular context comes and user is posing a query, you can say, okay, in my whole history of conversation, I have already seen a similar query like that, right. If you have seen a similar query, you may return the response to that query, right. That may be one possible way to deal with that. You can of course do multiple kind of retrievals. You can say, okay, I'll also match the context. So the context plus query should have a large match, then only I'll use the retrieval. The other kind of architecture will be by generation. That is, okay, so I have the context, I have a query, so I'll feed it to the encoder through the input, and my decoder will generate the response, right? So general encoder decoder, where you feed the context, the previous conversation history, and the previous query or the previous turn, and get the response as the decoder. Yeah, and this is one. I think this is the main preferred model. You can use encoder decoder, but right now people are also using just decoder only models for handling the same task, right? So generative models are typically more preferred, but you can see, I mean, in terms of architectures, so they are similar that we had in the case of QA also. You can do by retrieval, you can do by generation. Now, the corpus based chatbots are very data intensive, so require like millions and millions of conversations and billions of words. So where do we get these conversations, right? So there are some conversations that are already available, like telephone conversation between volunteers. So it's the switchboard corpus of American English, telephone conversation. So this is one data set that can be used. Then one can use movie dialogues, because in movie people converse with each other, and these subtitles are available. So you can even use it in multiple languages. So that is another data set. Now one can also create these data set by hiring crowd workers. So for example, topical chat was 11,000 conversation, crowdsourced on 8 different topics. Empathic dialogues had 25,000 crowdsourced conversation. So where a speaker was feeling a specific emotion, so you ground it on that, right? So you can annotate based on certain annotators. And then you can use, I mean, with the proliferation of social media, you can use the conversation that people are having on social media, because these conversations can be seen as dialogues, right? And you can even create multiple conversation trees out of that, and use different I mean, you can use every separate tree as one possible conversation. So you can use Twitter, Reddit, Weibo, etc. And Reddit has been one of the main popular source of data for training, like, I mean, for getting large data for training conversation models. Of course, they are going to be noisy, and they are used just mainly for pre-training the large models. Now, there have been some recent data sets, like Open Assistant is one recent data set where you have like 161,443 messages in 35 languages. They are human annotated, and then with all these large language models coming in, you also have conversations that you just had with LLM. So like ShareGPT is one data, so where you can use using the ShareGPT API, these conversations were collected, and this is again a very good source of data that can be used. While you are using data from some publicly available source like Reddit and all, it's important that we remove personally identified information from that. Okay. So now let's talk about the methods. So we talked about retrieval methods. So that is very similar to what we saw in the question answering setup. So let's say you have a user turn queue, you were training corpus of conversation. So you want to find out the turn that was most similar to queue, right? That is the idea. So you can take encoding of the query. So you can use the by encoder setup. You have the encoding of the query, and you encode all the turns, right, that you had in the corpus, and find out the most similar R, right? Now you can return the R, or you can return the response to R, right? I think that people have seen that if you return the response to R, that's better. So you take the response to R and return as the response to the query. Yeah. Then you have the response by generation. So architecture is just encoder decoder. So let's say this is my conversation. So I finally got promoted today at work. Congrats, that's great. And then you have this particular user query or prompt. Thank you, I have been trying to get it for a while now, and you have to generate a response to this. Right? So what you will do, you feed all these turns in the encoder, and you can put some separator between these turns, right? Or at least between the context and the current query of the user, and then you start generating in the decoder, right? So it's a normal model. So you generate each token of the response by conditioning on the encoder, where you have the entire query and whatever response you have generated so far. So let's say generating this, so you condition on everything before and the input, right? So this is your normal conditional language model. So you generate a word given the query and whatever you have generated till now. So, this is the standard encoder decoder architecture. Now, people saw that when they train this encoder decoder architectures for chatbots, so you can take a transformer model and train this. You can use an LSTM encoder decoder and train this. So, they found there were many issues, like you were finding they were getting repetitive and boring, right. So, like these are some typical conversation. Where are you going? Going to the restroom. See you later, and then this just keeps on repeating. So, this conversation. How long are you? How old are you? I am 16, and then the system goes into I don't know what you are talking about. So sometimes this happens. They keep on getting repetitive and boring. Okay, and because that may happen because they are preferring some data set, that some response that was very common, and they typically tend to repeat that particular response. So that's why just taking a encoder decoder model and training on some data does not typically work. So what people tried, you take a large language model, and try to pre-train it on this large data. So for example, dialog GPT was one such attempt, where they started with GPT-2 and they continued pre-training GPT-2 on conversation from Reddit. They will filter the long utterances, and also they try to filter the non-English utterances, URLs, toxic comments from there, and they trained on 147 million dialog instances, and this showed very good response generation ability, right, so compared to the previous models that were available. So this dialog GPT was a model from Microsoft, and this became very popular. So people have also tried to combine the two ideas, like we saw in the case of question answering, that you can do retrieval and also do generation together. So you can do retrieve some relevant information, and then you give it to the language model, which can refine the knowledge and generate the response, right. So rather than just the conversation history that you have, you can also make use of some additional informative context while answering a question. For example, tell me something about Beijing, right. So it may not be answerable from just the context. So what the model can do, like Xiaoyi was a model. So it will collect some sentences from public lectures and news articles about the entities, and it also will search them based on some IR based methods, and it will use that information, right. So now what will happen? So you will retrieve some passages from Wikipedia, and now whatever you are retrieving, you will concatenate them, right. Same idea of retrieval augmented generation. So you concatenate these to the dialog context with a separated token. So you have the dialog context plus some more relevant information, right, that you have gotten by search. And now the encoder decoder model will see this input, the passage, and the context, and it will try to learn how to generate the response given all this information. So you have this extra information apart from what you had in the conversation history. You can search that particular entity, and you can get more idea about that. So this again has been a prevalent form of dialog modeling that you use, you typically search. Now another common problem that people have seen while building dialog models is that if we train on all of our data, it may be a mishmash of personalities. So for example, suppose you have this message, where do you live now? Response is I live in Los Angeles. Okay. Then you again ask, in what city do you live now? It may give a completely different response. So I live in Madrid. And then you ask, in which country do you live now? It is asking England, you, right. So you see all three responses to the same kind of question are different. So it does not have a consistent personality. While when you are conversing, you would typically want it to be very consistent. So how do you ensure that? So there have been different data sets around that. For example, personal chat data set, the data set where you are given a personality and you have to chat according to that. So learn how to stick to a personality, right. So here you can build a personality. I mean, it's given to you. I like to ski. My wife does not like me anymore. I have went to Mexico 4 times this year, and so on, right. Another persona, and then you have a conversation between these two persona, and you have to be consistent with your persona while you are conversing, right. So this becomes an additional objective while training the dialog models. So as I mentioned, we'll just see the architecture for BlenderBot 3. That was one of the latest model. It had 175 billion parameters. So given a query like, hey, who is your favorite F1 driver? it will go through various different kind of modules. You see here, it will go through internet search decision. Okay, given this particular turn, should I search the internet? I mean, sometimes you may not have to search the internet if it is just in the conversation, but here you may have to, because you want to know who are the popular F1 drivers, and from there you want to choose one, right? I mean, and then start discussing about that. Why is that person my favorite? So you have a decision whether I want to do search or not search, and if you want to do search, you generate a search query and you actually search internet and you gather some knowledge, right? And let's say you found some F1 drivers, and now use that to generate the response, right? So you will try to get some interesting fact, and maybe use the previous topic that has happened. So you say, okay, someone is my favorite driver. How about you? Who is your favorite driver? You come back and give a nice response, right? And it had a lot of different things, like how do you access memory, that this already has the persona, right? You maintain the persona of the person. So you have a lot of different memory store that was populated. You can read there, you can update that memory with whatever conversation is happening. So this was a very nice and interesting architecture, BlenderBot 3. But I mean, going forward, after BlenderBot 3, once ChatGPT came, then the field was completely taken over by these large language models, because they were trained to be assistants where they could also handle multi-turns, right? So you would say, okay, what is like the best dialog model right now available? We will typically say ChatGPT, GPT-4, and I mean variations. They can even reason with text, images, and all, right? So now, given this idea about how do we typically model these system, let's also see how do we evaluate these, right? So evaluation, typically this is a generation task. Here you are given a particular context and the query, you have to generate a response. You have to want to evaluate the quality of the response, right? So there are various ways you can do that. One is you can just say, okay, I have a ground truth, so I have a reference and I have some generation by the model. I want to see how close is my generation to the reference. These are called content overlap matrix. So how much is my generation matching the reference, right? Then you can also have some model based matrix, where you do not rely on just the content overlap, but you look beyond content overlap, right? Maybe semantic similarity, the words may not be matching, but the meaning is the same. But in dialogue, it's even more difficult, because even you can, for the same context, same query, you can have completely different responses that the similarity is maybe nearly 0. We will see an example for that. So you would also have to account for that. How do we evaluate such kind of responses? And then, I mean, for a generation task, human evaluation is always preferred, that if you can take some sample from your data, get the model outputs maybe from multiple models, and employ some humans, annotators, to annotate which output was good as per different metrics, like how engaging. So was it engaging, was it repetitive? I mean, you can have various different metrics. We just mentioned that in one of the slides. So you can also do human evaluation. So that is also preferred. So content overlap matrix are very standard. So they are used in machine translation and other kind of tasks as well. We will see that in summarization when we will discuss that. So what they do, so they compute a score that indicate the lexical similarity between the generated output and the gold standard, right? So how similar they are, and this is very fast and very widely used. So typically you tend to report the blue scores, etc., for a dialog model. So there are various n-gram overlap matrix like blue, rouge, meteor, cedar, etc. So they are used in the literature for matching how good is my dialog response generation, right? Now there are problems with these content overlap matrix. For example, they have no concept of semantic relatedness, right? So they will simply see lexical overlap. How good is the word? I mean, they will exactly match the word, right, to the store. Some metrics like blue, they won't even see if you are matching the lemma and so on, but other metrics too. So let's see. I mean, what is the case the way they may fail? So suppose this was your reference answer. Heck yes, and these are your model generated, some model generated answers, the responses. Let's say yes, you know it, both of these are positive, and yep, yeah. So yes, you know it, yep, heck no. These are 4 model generated answers. And now if you see these 2 are correct and this is also correct, right. These 3 should be the correct uh, responses, while this is not, right. This is not matching the reference answer, right. It's a different thing whether it can be a correct answer to the question, but it's not matching. Yeah, it's not matching. Right. But if you see the score, so let's say there are so you are computing the some sort of precision and so on. So let's say or F1 score. So you say okay, yes is matching exactly. So it has a very high score. You know it, still you are matching the exclamation. So you get some score. Yup is a different word, right? But it also is a synonym of yes. You don't match it directly, you get a 0, right? And heck no, you still match this heck, right? But it is yes versus no, still you get say 0.67. Exclamation is matching, heck is matching. Yeah. So what do you see here? I mean, heck no is not at all similar to the reference answer. Still it is getting a very high similarity. So it's a false positive. System is saying it's positive, but it's actually not, right? And yep should be the correct, I mean should be a correct response, but you cannot match it because no word is matching. So it's a false negative, right? So this is a problem with simple n-gram overlap matrix, that you will get both false positive and false negatives with each. So how do you avoid that? Typically we can use model based matrix. So idea is that we have talked about learning representations. So rather than matching the words directly, why don't we match the representation? Idea is that yup and yes will typically have very similar embeddings and representation, right? So use the word representation and sentence representation so that you can compute semantic similarity between the reference answer and the model generated answer, right? And I mean you don't have to worry about which n-gram do I take, 1, 2, 3 and 4, and you have the pre-trained embeddings, and you can use some distance metric to measure similarity, right. So now one of the very popular measure for this is BERT score that people typically report. So it is based on BERT, but you can also replace BERT by any other encoder which can give contextual representation. So the idea is very generic. So let's say this is my reference, the weather is cold today, and this is my candidate generation, it's freezing today. So what you will do, you will pass them separately through BERT model and get this. So these are 5 words, 4 words, you get this contextual representation, right, the final embedding for each word, right. You won't take the CLS here, you will take the individual word embedding. Now you can compute precision recall. So let's say how do you compute recall? So in recall what you do, your reference is here and this is your candidate. You see for each of the word in the reference, say what is the maximum similarity it has with any of the word in the candidate. So you find 0.713 is the maximum similarity, fine. For weather, max similarity is 0.515, for each 0.858, for cold 0.796, for today 0.913. So you find maximum similarity for each word in the reference with the candidate. Okay. So you find the maximum similarity for each word in your reference, right, with the candidate, and take an average across the reference words. So this is how you can compute recall. For precision, you will do the other way around. You will see, okay, for each word in the candidate, what is the maximum similarity it has with any word in the reference. Okay. So you compute recall, you compute precision, and you can compute F major. So this is how you can compute your BERT score. Now people have also tried using some term weighting, because not all the terms will be as important, like the and is are like stop words. They are not so relevant than the weather and cold, right. So you should focus more on the topical words is the idea. So you can use our concept from TF-IDF. I can use the IDF of the terms and multiply with the IDF. So you have the max similarity and multiply with the IDF of the word. So you can compute IDF by taking all the training instances. Let's say you have M instances, and see how often this word occurs in how many sentences out of that it occurs in, and M is the number of utterances. So it's the same formula, log of M by DFT, right. So So, this is how you can compute IDF, and you multiply this IDF with the max similarity, and also divided by this summation over all IDF, right. So, this is one way you can compute the similarity between reference and the candidate. There are of course various other variations of the matrix since Bird's score was proposed. Now, I'll end this evaluation part with saying that dialog evaluation is not so straightforward, it's very tricky. So, let's look at this conversation history. What are your plans for the weekend? I am thinking of going on a hike. If the weather is nice, do you want to join? That sounds fun. I haven't gone hiking in a while. Which trail were you thinking of, right? And let's say these are some candidate responses. So, take R1. We should go to Red Rocks Park. I heard they opened a new trail. It's actually the ground truth, and it is relevant. But what about R2? How about the summit trail at the nearby mountain? It has beautiful views. Now, it does not match much with the reference, right? But it's a valid response, and you should still say that this is a correct response, right? So, now how do you evaluate such a response? You cannot directly compare, because same query may have multiple different responses which may be totally unrelated to each other, but still completely valid to the context, right. So, that is where there is the idea of reference free evaluation, that suppose I do not look at the ground truth, okay, but I just look at the context. Given the context, is my response a good response or not, right. But how do we do that? And the idea is that what if I pre-train my model on a lot of data where I have the context, and I show it the valid response and show it some negative response, and let it differentiate between a positive response and negative response. What if I pre-train my model by that? So, that has been, I mean, one of the another popular threads, that you can pre-train such models, and now once you pre-train the models, given the context, it can give a score to a new response that you have generated without looking at the reference. That given the context, what is the score for this response? If it is high, you can say it's a valid response. If it is low, it's not a valid response, right. So, this is one of the architecture, for example, dialog mutual information maximization. So, they pre-trained it on top of BERT, but the idea is that, okay, so you will have the context and the response. So, you will pass context through the same BERT encoder, you get the encoding. You also pass the response through BERT encoder, get the encoding. Now, you have some weight matrix, that is learnable parameter, use that to get a score, right. And then now the loss can be simply minus log e to the power, so I call it FCR, the function between C and R, E FCR divided by E FCR plus E FCR prime, where R prime are negative samples, right. So, you can use a loss in this particular form, and this is again very similar to what we saw in negative sampling. So, you have a positive sample, some negative samples, use them to train the model, and now once the model is trained, you have the context response, it can give a score to that, right. So, this is another important paradigm for evaluation of dialogues. Finally, you can do human evaluation, where you can select some dialogues, give proper instruction to the humans on what do we mean by say different aspects that you want to choose, like fluency, coherence and consistency, factuality and correctness, common sense, style, formality, grammaticality, typicality, redundancy, right. You may select which of the aspects are relevant for your use case, and you can evaluate that based on certain human, right. You can give them a form, and you can ask them on a scale of 1 to 5, how do you rate them, okay. So, yeah, I mean, we talked about some of these aspects. So, chapter 15 of the NLP, the SLP3 book talks about it. We will still have another lecture on dialogues, where we will talk about the task oriented dialogues, how do you model them, and what are the evaluation paradigm for that. Thank you.